OS level call. If you see the file over here is we have the entire command with us. We are back to the exec command, but now what is the statement that is going to be run? Select all from the SQLite master. Because we have given primary key, it is internally creating an index. What is the SQL statement? Insert into SQLite master. The values are, this is the index. As soon as we saw primary key, here was the second part of execution. See what is the statement? Update this set type table demo DB journal. There is demo DB journal. There is no journal. When I started my journey as a software engineer, I used to always think that only these super cool software engineers would be able to understand such complex code of databases. So yes, this is a dream come true for me also. As a teacher, this has always been in my to-do list. Because my ultimate goal as a software engineer, as a teacher, is to make such complex topics simple and to cover them in depth, right? So yes, welcome to another video in the free course of Databases in Depth by Educosys, where we not only cover databases in theory, but also debug the internal code. And yes, we are starting with SQLite, which is one of the most simplest but one of the most famous databases in the industry. This is the perfect database to get started with. We are going to be debugging the code. This is going to be super interesting. Thank you for showing up. Without wasting any time, let's get started. But before we get started, just one small thing. Although this is completely free for you, if you could just hit that subscribe button and if you could just share it with your friends or anyone who is looking to become a better software engineer, it would mean the world to me. It would mean so much. All my effort, all the effort behind this entire series would be completely worth it. So thank you so much for that. And now let's get started. Since we are going to be debugging the code, the first question that comes is, how are we going to compile and run such a huge project? Because if you see the source code, there are so many C files, it looks huge. How do we compile this? How do we run this? Because SQLite is supposed to be a very simple database. It is supposed to be embeddable. You are not required a different process for it. You are not supposed to have any extra configurations, nothing. It is supposed to be simple to use for small to medium level applications. So how is that going to happen? So if we open the official documentation of SQLite, and if you just go to this download button, you are going to get this page. So SQLite download page. And if we see the first zip file that we can download, it says SQLite amalgamation. See source code as an amalgamation. What does that mean? Let's see some more documentation. Here it says how to compile SQLite. So if we read about it, it says the use of the amalgamation is recommended for all the applications. Building SQLite directly from the individual source code files, that means from the GitHub source code that we just saw, is certainly possible, but it is not recommended. Then what is recommended? For some specialized applications, it might be necessary to modify the build process in ways that cannot be done using the pre-built amalgamation, which is fine, not from the website. But for those situations, it is fine. But other than that, use the amalgamation. What does that mean? So let's see. See, SQLite is available as a pre-packaged amalgamation source code file, which is SQLite3.c. I know you might be a bit confused right now. Just stay with me for a bit. Amalgamation file is a single file of C code that implements the entire SQLite library. This is much easier to deal with. Everything is contained within a single code file. So it is easy to drop into source tree of a larger C or C++ program. What does this mean? Let's actually see the SQLite3.c file and let's try to understand. So I've opened the SQLite3.c file, and if we see over here, it is written begin file SQLite int.h. What does that mean? So if I just see begin file, do you remember we saw this in the starting of every single file when we were going through the code? And let's see what is actually happening. So if I just search for begin file, I've searched for begin file. Can you see there are 138 matches? And if I just keep going down, you can see vxworks.h, SQLite3.h, SQLite3r3.h, session.h, something.h, limit.h, hash.h, parse.h, os.h, ossetup.h, pager.h, vtree.h, vdbe.h, opcodes.h, pcache.h, mutex.h, oscommon.h, ctime.c, global.c, status.c. So all the C and H files together, I think you are getting my point. And if we go to the top of the file, you can see what is written over here. So this file is an amalgamation of many separate C source files from SQLite version. By combining all the individual C code files into a single large file, the entire code can be compiled as a single translation unit. This allows many compilers to do optimizations that would not be possible if the files were compiled separately. Even performance improvements of 5% or more are commonly seen when SQLite is compiled as a single translation unit. So even I was trying to compile all the source code separately and doing all of that. But when I read the documentation, I was like, oh, this is just so cool and so easy to use. And that is why SQLite is famous, right? So this file is all you need to compile SQLite. To use SQLite in other programs, you need this file and the SQLite 3.h, which I have right over here, SQLite 3.h. And what it is saying is that this is what you need that defines the programming interface to the SQLite library. And there are more details mentioned that we can keep reading about it. And if we come back to our official documentation, you can see that a build of the command line interface requires 3 source files, SQLite 3.c, SQLite 3.h, and it is saying it requires one more, shell.c. So what this does is it contains the definition of main routine. So what I have done is I downloaded from here only, and when I downloaded there were 3 files. But what I have done is I have written my own main so that I can show you whatever commands I want to run. So let me show you that. So here you can see 3 files, SQLite 3.c, SQLite 3.h, and then there is one main file. This file I have written. So this is a simple main function, and inside this is what I am doing, and we are going to be debugging. So open the database, create table, insert, all of this, right? So I have commented the insert, update, delete for now. But what we are going to be debugging firstly is the create table, then insert, then select. We are going to be debugging like this the entire thing. As you can see, I have put breakpoints literally after every single statement in main. So it is going to be very clear. We are going to go one by one. Our major focus is going to be on the create table statement. Although it looks very simple, create table statement, there is a lot more that goes behind it, and we are going to see how much is there behind one single statement. For now, let's get started with a simple open database statement, and I'm going to build it and run it for now. So you can see I have a lot of breakpoints, and I'm going to show you the important functions that are going to be hit. And I'm going to be using the cursor as much as possible so that you know exactly what I am doing. Here can you see right now there is inside DB. If you see, there is already VFS, VDB. Do you remember these terms, VFS, VDB a bit? Yeah. Let's see what exactly is happening. Let's go inside open. And if we use open, or if we use open version 2 internally, open database is called. So let's go inside this and let's see what's happening. So if we see the file name was demo.db, that is what is sent, that you have to open a database with this name, demo.db. And there are a lot of things that happens. You can see there is initialize and all of this, but let me show you the most important things. So for now, there is B tree open, correct? So you are opening the B tree sort of. And if I run it again, see, here comes the interesting part. So this is a OS level call. If you see the file over here is users, Keerti Purswani library, developer, Xcode, something, SQLite test, and build products debug. So let us see what is there in that folder right now. So let me just go to the command line quickly, and let's see what is there inside this. So right now there is only SQLite.test, and now let's do this. Let's run just this one line and let's see what happens. So we are inside robust open, and if we go back and run it again, can you see demo.db? So that is where the exact file was created. Where? So if I show it to you again, this is where, because you're opening the file, right? So you are opening the file with, okay, if I just come like this, you will be able to see. This is where B tree open, pager open. So remember B tree to pager. So here you can actually see it happening. And this is the Unix open. So it got run. And everywhere, if you see in the Unix open also, what was the name that was given? Debug. And if you see the entire name over here, demo.db, demo.db. And this is the one that got created, correct? And we are inside this right now. So right now I just wanted to show that where it is being created. And if I just quickly run it, now we are going to be in the create table. And let's quickly just see what else is there. Right now our condition is there is demo.db and there is SQLite test. Before we run create table statement, let me tell you that internally there are a lot of commands that are going to be run in create table, and it can be overwhelming when we directly debug. So let me give you some context and let me tell you exactly what is going to happen so that you have some idea and you know that why so many commands are being run. So let's do that. Before we move ahead, I would just like to take a minute over here to tell you that if you're preparing for interviews or if you're looking to become a better software engineer, I would love to be part of your learning journey and make it easier, faster, better, and more fun. I teach live, plus you also get access to the recordings so you can learn at your own pace, and you get a consistent teaching style because I teach all HLD, LLD, DSA, project-based courses where we cover industry-level projects like YouTube, WhatsApp, Zerodha. We cover MERN stack as well as DevOps, and we also have C++. Plus, if you sign up for any of our courses, you get lifetime access to all the batches, the past, present, future, everything. You also get access to our mock interview platform. You can come practice anytime. We are going to guide you. We obviously have doubt support as well. We are putting our heart and soul into teaching. So if interested, at least check out the site. All the detailed curriculums, the testimonials, the answers to all the general FAQ, everything is present over here. Just check it out. Educosys.com is the site. Plus, if you still have any questions, feel free to reach out to us at support@educosys.com. We will also guide you about what is better for you. At least check out the testimonials for now.
The best thing that I like about Educosys is their courses are live.
Keerti herself, the way she teaches, the way the courses are structured are actually the best part.
Their live classes and the very helpful Discord community.
I feel very confident as compared to what I was before these courses as a software engineer.
My experience at Educosys have been really great.
I feel more confident as a software engineer after enrolling in Educosys.
But for now, let's get back to the video. This is the exact create statement that we are going to be running and debugging. So what is going to happen is first we are going to tokenize and understand and parse it. So first we are going to come across create token and then we are going to come across table. So we know we are supposed to create a table. Then we are going to see that when we come across this starting of the bracket, we know that we have our table name now. So what is the table name in our case? It is courses. So we know that we are supposed to create a table with the name courses. The first thing that we are supposed to do is make sure that whatever DB we have right now, there is no table or index with the same name. It is possible, right? So while our debugging, this is the first table that we are creating. But in reality, it is possible that there was another table or index that was created with the same name. And if that was the case, SQLite is supposed to throw you error saying that there is already a table or index with the same name. So we are supposed to do this checking. Now, how do we do this checking? First thing that we have to do is we have to go through our database and see what are the present tables, what are the present indexes. They can also be triggers, views. So we have to first go through our database. So how do we do that? So for that, what we have is there is another special table that is created in SQLite, which is called SQLite master. So this is a special table that is created and it has the schema of all the tables, indexes, triggers, views that are created. I will actually show you. The first statement that is supposed to be run is the select statement. So what we are going to do is we are going to run a select query on SQLite master and we are going to see that what are the present tables and indexes, what are their schema, is there any table or index with the name courses already or not. Now, when is this SQLite master created? So because till now there is no table or no index that has been created for now, right? In our debugging, we just created the database, nothing else has been created. So in that case, there is yet another query that is going to be run. And the first query that is going to be run is going to be a create table query. So first we are going to create the table and we are going to create what? We are going to create the SQLite master and I will actually show this to you. And then we will run a select query to see all the tables and indexes that are there to read the schema. So this is the create table SQL command that we are going to be executing. So here we use SQLite 3 open. Now we are going to be running this command SQLite 3 exec. Here you can see we'll be passing the query as well. So let's do that. Let's go inside this exec function. So if we come over here, we have passed the entire query, right? So initially, what is the first thing that we are supposed to do? We are supposed to tokenize it. So for doing that, firstly, there is going to be a prepare function that is going to be hit. So first we are going to take a log and we are going to prepare. So there is going to be b tree log. So we are going to take the mutex and all of that. And there's prepare. the main function that we are supposed to care about is this SQLite 3 run parser. Do you remember we saw this? So here we have the entire command with us. What we are going to be doing now is actually see the while loop, and we will see that okay, create table, it is tokenized, and can we see the tokens or not. So let's continue to the while loop. So see, while loop is going to start from here, and let's come inside this, and now you can see the entire SQL statement. Right now, what is the token type? So as soon as we get the token, right now the token type is 17. Why 17? So if we go inside this and see what was the token type for 17. So let's see, 17 is create. See, so what did we do in get token? You remember we actually saw this code. So if we go to get token, we had seen that we see one by one that what it is, right? So right now it is create. The next one that is supposed to come is space, right? And then after that table. So we are going to go one by one like this. So there is a while loop, and if we see this while loop is still where? So you can see the while loop is still here, right? And let me just continue and come back to the next iteration. So see, the next one is 184. So if we go inside this and see what is 184, so it is a space, right? So create space. The next one is supposed to be table. So if we go up and see what was the number for table. So for table it is 16. So the next one should be 16. So if I just continue again and I hit this breakpoint, so you can see it is 16 for now, and let's go to next and see what happens. So the last token is saved over here, and you can see the statement is also trimming off, right? Like because we have already taken care of create space, and now we are dealing with table. So one by one, see, here is where we are, n is the size of the token, right? And now that is how we are moving. This is like a simple while loop that we are just moving to the end of the next token, right? And just we moved over there. So now we are at space courses. So if I just do again, right now the token type is 16, and if I go to the next line, you can see that it is 184. Why again? Because it was space. So now we are going to be dealing with space. If I continue again, so now we are going to be starting with courses. Now what happens in courses? See, it is 59. What is 59? If we jump to the definition and see what is 59. See, 59 is ID. So there is some ID that is there, correct? Courses is an ID. Now let's see what happens. So where are we going to go? So there is also parser over here, right? So if you go inside this and if you want to see, this is how the parser looks like. Remember we saw this entire thing that this is how the lemon parser looks like. So we can keep hitting this again and again, but why to see the parsing code? So I'm just moving ahead. You know exactly what is happening, right? If I move ahead now we are going to come across this bracket. So we know that we have now the name, and now we are supposed to see, we are supposed to read the schema. So let's see how that is going to happen. See, what is the token type right now? It is 22. Let's see what is 22. So if we go back over here and we see what is 22, say it is LP. So I think it stands for parenthesis. And if we go inside now, see, so when the parsing happened, I had put a breakpoint over here. Now it is saying that you have to start the table. So this is where we are going to start the table. See, all the parse structure is there. So inside this you can see VDB and all of this is null right now. Let's go inside this and let's see what is going to happen. So now we know that we are supposed to start creating a table, right? Now comes the interesting part. So now we have tokenized till create table, courses, and then bracket. So we know that we are supposed to start a new table. So what we are going to do is we are going to initialize. So can you see over here, we are going to try initializing something. So firstly, okay, let's move ahead for now. So you can see that the name is there. So, okay, let me just show you the name. Give me one sec. Yep, can you see it over here? So this is the token. So here the entire thing is passed over here. So what is the remaining token has been passed. So let's go ahead. We are doing some auth checking and let's move ahead for now. Now can you see we are going to read the schema. This is exactly what I was talking about. make sure the new table name does not collide with an existing index or table name in the same DB. Issue an error message if it does. So here you can see we can issue an error message that the view already exists or the table already exists. Okay, there's already an index name this. So if there's an index name this, we can also say that. Okay, so we have to first of all read the schema. So let's go inside this and let's see that how do we read the schema. Okay, and if we go inside, here is where we are going to be reading the schema. This routine is a no-op if the DB schema is already initialized. Because the schema is not initialized yet, this is the first statement that we are going to be running. So that is why we are going to run the initialize. And let's go inside this. And because this is the first time, we are going to be going inside the init function. And you can see we are inside initialize. Initialize all DB files. The main DB file, the file used to store temporary tables, and an additional DB files created using attached statements. Now let's see exactly what is happening. Next very important function that we should be looking at is init1. And let's go inside this and let's see what is happening. So if I go inside this, you can see that some transaction, okay, right now I think I can continue. And let me just continue for now. And see, I am inside init1 and you can see there are some things that have been done. And here you can see we are forming a new statement saying create table X, type text, name text, table name, root page and SQL. This is the schema table that we are creating. Okay, this is the schema table and the name we are going to give it SQLite master. So in this file actually if I just search for SQLite_master, so you can see there is a legacy schema table that is going to be created. Similarly, there is a temp master that is going to be created, legacy temp schema table. So what we are creating right now is the legacy schema table. So if I do next, here you can see this statement is saved in this argument. And what we are going to do is in this callback, we are actually going to execute this new command. So this is a new command altogether. So again, whatever we have seen so far, so prepare, lock and prepare, run parser, all of this is going to happen again for this new command. So this is a new SQL command altogether. So within a create table command that we are running, internally there are a lot of commands that are going to be run. So here you can see we are constructing the in-memory representation schema tables. So SQLite schema or SQLite temp schema by invoking the parser directly. So now this entire table is going to be created. And interestingly, the schema of this schema table is also very important because you will see that within this table, we are going to store schema of all the tables, indexes, views and triggers. So when you see type, type is going to signify. So here can you see the type? So what we are going to pass is a table because we are creating a table right now. So in the type, we are going to say whether it is a table, it is an index, it is a trigger or a view. Then this is where you're going to store your table name. This is the name of the object and this is the root page number. So you remember every B tree, so there is a root page. So this is the page number of the root page of the B tree, right? And this is where you're going to store the entire SQL statement that created this particular table or index. And you will see later also when we are going to compare the schemas, you will actually see that the entire SQL statement that you were running. So in our main that we are saying no create table this is actually going to be stored as it is within this schema table because the entire SQL command that was run to create this particular table or index or trigger or view, that entire SQL command is going to be stored so that you can check the schema of that also. So whenever you're going to insert, it is going to validate that see this was the SQL command that created this particular table. Now you are saying to insert, is the schema matching or not? Because how will it do the validation that okay, you are not sending any particular field that is supposed to be not null or primary or something like that. So this table is going to give you the entire schema. So that is why this is a very, very important table. So see, this is where we are saying that this is going to be a statement. So if I continue now, see now we are in callback and if we go ahead, so if I just go ahead and continue actually, you will see that I am going to prepare. And what are we passing? The fourth argument. What was the fourth argument? The entire SQL statement that we made there and we passed, right? So this is a huge code, but I am showing you the most important thing. So we are in the init callback right now. and we are passing that fourth argument, and this is where this statement is going to be there. And see, right now we are back to prepare. So where did we start from? So from our main we went to exec, to prepare, to run parser. Now again parser will be run, but if you see now what is the statement, that it is the new statement. It is not the statement that we gave in main, it is the statement to create the SQLite master table. So if you see, this is the type, table name, root page, SQL text. Again, if I continue, now we are going to again parse this. Again we can see the while loop. See, again you can see the tokenization. Here you can see right now it is 17 create, and if I do again it is going to be space, so 184. If I do again, now it is going to be 16, so 17, 184, 16, just how we saw earlier. And if I do again, so it is going to be of the type 184, again space, and if I come now it is going to be 59, which was ID. And if I continue again, now let's see what is going to happen. Again we are back to start table, but now what table are we starting? The SQLite master, and not the table courses that we were supposed to create. So this is interesting, right? And if we go inside this, see, if we actually see the names right now, so here can you see this entire, see type, text, this, and X is going to be sent separately. So if we see, you will actually see the X name as well. Let me just show it to you. So here, can you see right now? No. See, now when we read the schema, okay, so I pressed continue, but what you saw was that right now init was not hit, because this is not true now. We are not going to get inside this because we have already set the state and we are creating what? SQLite master. So if I move ahead now we have said it, okay, we are going to start creating the table, and this is what we are going to be passing. So now we are going to tokenize the rest of the SQL statement. So we are inside the while loop. So there was type, which was of 184, then there's going to be space, then 59, right? So text, comma, so if we see 59 again, and if we do name, then can you see this moving? So text, then text is gone now, comma. So we are just going through the rest of the statement. So we can debug it like this. So root page, space, int, comma, SQL, and then text. So right now we are just tokenizing and parsing the rest of the entire statement. And what is going to be the important moment now when we come across the bracket? That means that now we have all the things. Now we are ready to create the table, right? So if I do continue now you can see we are in the end table. What does this mean? This means this routine is called to report the final this that terminates the create table statement. So now we are saying ki now we have tokenized past the rest of the statement. Now we are at the end of the create table statement. Which create table are we doing? Create table of the SQLite master. So we are at the end of that. Let's now see what happens inside this. So when we are at the end, so here we are just checking and we are going to set some flags and everything and initialize the entire table. So schema to index, and I'm just going to continue for now. And here we are saying parser finalize, because whatever engine was there, now we are done with the creation of SQLite master. And I'm going to continue again. And now we are in SQLite 3 finalize. So do you remember while executing any SQLite command, so we go through SQLite exec and then there is finalize. So this is finalize for what statement? So the statement was the creation of that. And here you remember, so whatever statement is there, that becomes the VDB, the engine, and let's see. So right now there is no statement, so we are just going to go ahead and we are going to see the finalize in the next statement, so that's fine. And let's just go back. Let's just move ahead. So now we have created the table. We have created which table? We have created the SQLite master table. So this init callback is now done. So a quick recap from the create table of courses that we were creating. We went to read schema and then we saw that okay, nothing has been created till now. So we have to create the schema table. So this is where we created the schema table. We are done with initializing the schema table. So now what is the next thing that we are going to do? If we move ahead, okay, if we move ahead, so you can see there is, so B tree transaction that we are starting. Now that we are clear with that much, you should know that we are still in our init. Okay, so I'm just going to continue and go to the next important thing. So right now, just know that this is the huge function where we actually created the table. So created the SQLite master table. Okay, so we are still inside init1. So if I just go to next, we are still inside that, but now we are going to run yet another SQL command, which is select all from. What is that we are selecting all from SQLite master. So the very first table or index which will be created, at that time we will be creating the table. But if that is done, see, the create table statement is not going to happen again and again, because this was the first table that was created. That is why this was called. So if you see, init busy is the variable that they are setting to see that, okay, this is the first time that we have to create. Now that it is created, what we are going to do is we are going to select all from it and we are going to see the schema now. So now we are going to see the schema. So now next time also when you create a table in this database, every time you create a table or index or anything, this will be run. So if we come inside this, we are going to select all from this, and now we are going to execute a select query. So within a create query, we have now run a create query, and now we are running the select query. And if I just move ahead and if I just do continue, so we are back to the exec command, but now what is the statement that is going to be run? Select all from the SQLite master. And from where did we call this? So we were just over here right now, right? SQLite all from the master table. We just saw this. So we are just inside this right now, and there's also an init callback inside this. Okay. So if I just continue, this is the statement that is going to be run. Again, we are going to prepare. So if I do continue, again we are in lock and prepare, and again we are in prepare, and now we are again going to be where? Run parser. But now what is the statement that is going to be passed? Select all from. So if I again do continue, again if I tokenize this, what is the first token that is going to be there? 138. Let's see what is 138. So if I jump to definition and see what is 138, so you can see 138 is select. So it is what? Select all from. So the next one is supposed to be asterisk, which is all. So if I just do continue, the next is 108. So if we again see what is 108, so let's see what is 108. It is star. See, so select all, and the next one is supposed to be from. So if I just search from over here, okay, it will start searching in the entire file. Let's just go ahead and let's see what is the next one. So what is the token type right now? It is 108. If I run again, it is 142. Again, let's jump to the definition and see what is 142. It is from. See, so select all from, and if I do continue again, here you can see 141. Again, what is 141? So if we go to the definition 141, it is dot. Okay, so this dot, it is trying to see. Then we are going to come across SQLite master, and then next is 59. 59 was what? I think ID, correct? So 59 is ID, because SQLite master is ID. Next should be space, which I think was 184 or something. Let's see. Yes, space is 184. So if we run it, the next is space, which is 184. Now then it will be order, then again 184, then by. So if we do continue again, it is 145. So 145 should be order. If we see 145 is order, then it should be 184 again. Yes. And if we do continue again, it should be by. So if it is 34, let's see. 34 is by. And see, right now I am showing you only the tokenization part, but within this while loop, every single time we are going to the parser also. So if I just put like a debugger inside this, if I just do this, you can see that within every while statement we are coming inside this only, and within this there are if and else. So now you should be able to understand it how tokenization and parsing is happening properly, right? So if we see over here, there is a while one for parsing also. So if I just continue, we'll be back over here, and it is again space. And if I continue again, now there will be row ID, and again we are going to be parsing. And if I continue now, let's move ahead, and now we are in select, right? Where did we go from select? So in our reduce, just how we came to start table, right? So if you remember over here only, there would have been a start table somewhere, and that is where all the if else are there. So there is drop table, create view, drop table, and select, and there would have been a breakpoint over here somewhere for start table that we just hit the last time. Right now we are in, so yeah, you can see over here, correct? So you can see add not null, add primary key, create index. So all of these will be hit. So right now we are in select, and let's move ahead. So what is going to happen is now we are selecting the information. We are getting the information from where? We are getting the info from SQLite master. So that is the table that we are reading. Let's quickly move ahead and see what is going to happen. So this is select expander, and this is how selection is going to happen. I think we can just continue. So see, we are reading the schema again. Right now it should not go into the if statement. So because initialization has been done, right? See, it did not go into the if statement. It is going to go inside the if statement only the first time. Only the first time we are creating any table or index or trigger or view, only the first time it is going to go inside that, after that not. Okay, and right now we are going to go to find table. We are going to find a table with the name SQLite master. So you can actually go inside this, and when we do find table also, it is again going to check in the DB only, right? So it is going to compare, is there anything with the name SQLite master, and then it is going to compare one by one. See SQLite underscore, and it is checking. Are we finding the schema table or the temp schema table? So we are finding the schema table, right? So if we go actually ahead, so we are going to locate the table now. I'm going to just continue from over here, and we are in parser finalize, and let's run it. And now we are going to execute the statement. Which statement are we executing? We are executing the statement select all. So what did we do till now? We just prepared the statement, all the initialization happened. Where does the actual execution happen? In the step, right? So if we go inside this, see, you can see this is where the execution is going to happen. So now we have the prepared statement. So now we are moving from the front end to the back end of SQLite, correct? So this is the top level implementation of SQLite 3-step. Call SQLite 3-step to do most of the work. So this is where the actual work is going to start. If you can see, the prepared statement is now typecasted to VDB, right? VDB is our first component in the backend of SQLite. So we are now in VDB. We are taking mutex lock, and let's move ahead. So do you remember what exactly happens in VM? VM is nothing but a huge switch statement, and there are opcodes within, right? So this is the opcodes, and there are operands and all. We will not be discussing up to that level, but you can see the switch statement. So can you see the switch statement being executed one by one? So if I just move ahead, and if I just show you. See, this is the switch. So this is where we are going through every opcode one by one. What follows is a massive switch statement. So do you remember in VM, there is only a huge switch statement, right? That is why understanding the basics is very, very important. So here there are some opcodes, and there is a switch statement in the VM. So let's continue for now. And I just wanted to show you the switch statement once, and I'm going to remove the debugger from there and just going to continue. So this is VDB halt. So now VDB part is going to be finished. Let's move ahead. And you can see B-tree commit phase 1. So a quick recap of exactly what is happening. So we are executing the select all statement from SQLite master. So we were in the exec statement, right? From there we went to the step. This is where the actual execution happens. And now we have the prepared statement. So in the step is where we are going to be typecasting the statement, the prepared statement, to the VDB pointer. So now we have the VDB pointer, and then we saw there was a huge switch case that was executed for the opcodes. Now from after the VDB component, what is the next component that is hit? It is the B-tree one. Now in B-tree there are two phases, phase 1 and phase 2. And B-tree component will be using which component? The pager component. So within B-tree phase 1, you can see there is pager commit phase 1 call, and similarly within B-tree phase 2, we will be able to see pager phase 2 call. So right now there is a select statement, right? We will see the commit phase 1 and phase 2 execution later. For now I am moving ahead from phase 1, and now we are going to phase 2 for the B-tree. And if I go ahead in the B-tree phase 2, See, if I just go ahead and I am outside, and now we will be doing the commit, and if I just continue for now, and we are going outside the VDB part, and I think we can just return. If I just go out, I go out. So we are coming out of this step, right? So we are coming out of this step. If I just continue, VDB finalize. So we are doing what? We are doing the cleanup and delete the VDB, okay? And we DB free. And right now we were executing what? Select all statement. So remember that. Again, phase 1, phase 2, init 1. And now let's move ahead and see where are we. So the create table part is going to get executed again. Let's move ahead, call back, prepare, again prepare, parser. What is the statement right now? It is create table. I know the question right now is how did we get into create table all over again with the type text name? So this looks like schema of SQLite master, right? How are we creating SQLite master again? So no, we are not creating SQLite master. We are creating a temp master. I know it can be confusing. Just stay with me, stay patient. How tokenizer part is now completely clear, right? Slowly it will become clear. Let me do a quick recap for you to completely understand what is happening. We started from create table courses. Then we did a create table of SQLite master. Then we did select all from SQLite master. That happened. Then we were still in init and still create table is called again, right? Create table is called again. But now what is the X value that is passed? So now let's see that, right? So if you go ahead and come to the parser, and if I just go right now, so the value of X should be what? So if I move ahead and I just do this, and let us just actually go to create table, and I'm removing the breakpoint from over here, and I'm just going to go directly to the start table now. See, start table. What is the name of the table that has come? Let's see. So let's move ahead. Let's move ahead. What is the name? So it is a schema table is what we know. And let's move ahead. Let's move ahead. Just stay patient with me. Stay with me. Okay, we are checking. Is it already there? We are doing some auth check. We are moving ahead. And now we are reading the schema again. Okay, I know it can be confusing. Stay with me. Stay with me. Come on. Read schema, find table, and let's see what is the name. SQLite temp master. So you remember when we saw SQLite master, the legacy table. So if we just search SQLite underscore master, if I just search that, so there was the legacy schema table and there is legacy temp schema table. Now when is this created? Why is it needed? So this is to store schema of the temporary objects. So whenever we are creating a new schema, no, this schema table is created, the temp schema table is created. So this temp schema table is responsible for temporarily holding the schema information because we are creating a new schema in SQLite master, right? We are creating a new entry altogether. Because we are doing that, temporarily we are going to store it in SQLite temp master, and that is why we first have to create the SQLite temp master. So the first create statement is actually going to be a lot more complex, the first create table statement of the entire DB. But once all of this happens, you don't have to keep creating SQLite master over and over again, right? Because it has already been created. So after that, things become much more simpler. But because this is the first time, it is also interesting because you will be able to understand, right? So now what we are creating the SQLite temp master. So if I just run right now, and now we are back to type text this. Now what is the remaining? This we are creating again the SQLite temp master. So I am going to run, see text, comma, name, just notice over here, space, text, comma, just keep noticing this, table name. So the schema is same only, it is just for temporary objects. So the schema of SQLite master and SQLite temp master is same only, that is why all of this is same, correct? So text, comma, root page, space, int, comma, SQL, space, text. Now as soon as we come across this, what should happen? End of the creation. So end table. This is where we are at the end of the create table statement, right? So what are we ending? Creation of table of SQLite temp master. So I will run now, parser finalize, I will move ahead, and SQLite 3 finalize. We are finally done with creating the temp master. And let's move ahead. Now we are in which one? Now finally we are done with creation, selection of SQLite master and SQLite temp master. Now we are going to get started with the rest of our courses wala table. So if you go back to this, if you have forgotten, so this was the command that we were running. Till now we have run only this create table courses. Now ID, int, primary key, not null, title. So there are three things. One is the ID, title, and then duration in weeks. So if we go back over here, so if I just go to the next statement, here you can see ID, then title, duration, right? So right now we are in this bracket. So 59. So if I go inside this and see what is at 59, see 59 is the ID. So we are at ID, right? ID. Let's just run this now. Okay. Now when we come across primary key, what is going to happen? Now we have to register a primary key, right? Because when we say create table, it has to register somewhere that okay, this is a primary key. So that also should happen internally in SQLite, right? So currently the token is 184, and if I just go to the next statement and I move ahead, see as soon as I come across the parser, so this was the space, and as soon as I move ahead, can you see add primary key? So we came over here. See, we are in add primary key. How did we come here? From parser, again we reduced to add primary key. So as soon as we saw, okay, primary key space, then we saw, oh, we have to register a primary key. So inside primary key, if we come, what are we supposed to do? We are supposed to create a new index, right? This is exactly what is supposed to happen internally in SQLite, right? Because we have given primary key, it is internally creating an index. So let's go inside this and let's see how is the index created. So if I go inside this, see, now we are going to create index. Let's move ahead and see. Let's just go ahead. So again we are reading the schema. Again we are in init. Again we are going to see, okay, just give it 1 sec. So we are in init right now. Init is done. See, schema to index. So if we go inside this, if the same DB is attached more than once, the first attached DB is returned. Okay, so we are going to continue now. Okay, so now comes the next important part. Within create index, what is the next thing we are supposed to do? We are supposed to insert this index. Where is all this information of all the tables, indexes, triggers, views? In our schema table. So in our schema table, we have to say there is a new index. So inside our create table of courses, because we had given primary key, it is going to create an index. And what is going to happen when we create an index? We are going to insert that index into our schema table. What is the schema table? SQLite underscore master. And what exactly are we going to store inside this? So if I just do run, again from nested parse, what do you think is going to be called? If I do just continue, see run parser. What is the SQL statement? Insert into SQLite master. The values are, this is the index. What is the name? SQLite underscore auto index underscore courses underscore 1. So for the courses table, it is creating an auto index and the name is underscore 1. See, if we remember the scheme of SQLite master, how did it look like? So first was type. So what was the type initially? It was table. Right now it is index, because what are we inserting? The index, right? And this is the name of the index. This is the table name, the courses, right? And this is the SQL command that is going to be run, and this is what? It is the root page number. So that is 4. So let's move ahead for now, and we are going to parse. So let's again go inside the while loop. What is the token type? It is 127, and let's see what does 127 stand for. So 127 is insert, right? Because this is the first time we are seeing insert statement. We have already seen create. We created the SQLite master. We created the SQLite temp master. We also did a select all from SQLite master. Now we are doing insert index, right? And now we are running the insert statement. So I am going to run now. See, insert space and then into. So 151, if we see, 151 is into, correct? And if I do again, So insert into, then it will be main dot SQLite master space values and then this. And I am just continuing and moving ahead. And as soon as the insert statement finishes, what just happened? So in here you can see SQLite 3 insert. From here we came to insert. Just how we went to select, right? Now we are in insert. So here you can see there's a huge insert statement. So if we come inside this, now what we are going to do, if this is not a view, open the table and all the indices. So this is where we are going to open the table and indices. If I go inside this, you can see what all things are happening. Schema to index, and I'm going to continue for now. Again we are back and we are finishing the insert statement. Parser finalize, moving ahead. Primary key is now done. So back to our original statement, primary key is done. Now we are in not null. Okay, let's continue. So you can see not is done and then space. Now null is being executed. And as soon as I do this, you can see not null wala parsing is going to happen. And if we go inside this, it is going to mark it as not null, right? Because in our schema, it is supposed to update that it cannot be null. That is why the next time when there is any insert into the courses table, it will be able to check the schema and say, oh, this is not supposed to be null. So we're supposed to update the schema now, right? So I'm going to continue. And you can see text space not space null. Again not null will be hit. Then duration int, again not null will be hit. See, not null is hit. So if you go inside, you can see it adds the not null wala part. Okay, so it just updates the column that it is supposed to be like this. Now we are finally finishing what? The create table courses. Finally we are going to do this, and we are finally in the end table of create, right? And if we just continue for now. Okay, I know you're overwhelmed. Let's do a quick revision of exactly what has been happening till now. So this was our original statement. We went to create, we went to table, then we went to courses, and as soon as we came over here, there was a lot that started happening. So let's quickly write it down what all things happened. So when we came over here, we did first, because this is the first time we are creating any table or index or anything. So that is why the first thing that happened was create table what? The SQLite master, right? The SQLite master. Sorry for the handwriting. Now within SQLite master, what was the schema? So how does the schema look like? There is type, which was like index or table like that. Then there was name. Then there was the table name. And after that there was root page number. And then there was the SQL text, correct? So this was the schema of the SQLite master. Now after we created the table, what did we do? We did select all from the SQLite master. Why did we run this command? Because we had to check for conflicts. So check conflicts and gather the current state. So current schema state. So that is what we get from the select statement. So first we did the create statement, then we did the select all statement. After this, what happened was we did one more create table. Because why? Because we are creating a new schema itself. So that is why we are creating a temporary object, and for that we need the temp table. So now we did create table. It was for the SQLite temp master, and the schema of SQLite temp master is exactly same as this: type, name, table name, root page and SQL. So the schema is exactly the same, just that this table is for temporary objects and this table is for the main objects. Now one more important thing to remember, that in the select statement you actually saw that within step we did the VDB calls. So there was VDB exec and VDB halt, and after that we did the VDB commit. After that we did the phase 1, phase 2, right? And in phase 1, phase 2 we saw that there was B tree and then there was pager. So you saw the flow that in select what was happening, that first we prepared the statement which is like front end of the SQLite, and then once we had the VDB pointer, we did the opcode wala switch statement. then VDB commit, and then it used the B tree layer used the pager layer, and then the OS layer gets called. So all of this happened till we were over here. Okay, so this was like first part. So all of these were like the first part ka execution. Then we executed all of these tokens, and then we saw primary key. Oh, as soon as we saw primary key, here was the second part of execution. Because we have seen primary key now, what needs to be done? We need to insert a new index. So that is why what was the call that was made? That insert into, so insert into the SQLite master. And what were the values? So I am literally just seeing, okay. So the values were index, because that is the type, right? So that was the type. So here you can see the type. So the index was the type. Then the name was SQLite underscore auto index underscore courses underscore 1. So that was the index name. Then there was table name, which was courses. Then there was root page. If you saw, we saw something like this, right? That was the one. And then there was SQL statement, which was null. So we did the insert into statement. So this happened. So this insert into statement happened because of this primary key. And once this happened, then there was not null and all of this. And then once we ended, once this happened, now all of this is done. Now we have reached the end table. And from here, now we are seeing yet another command, which is the update command. Coming back to our update statement, now why is this happening? A slot for the record has already been allocated in the schema table. We just need to update that slot with all the information we have collected. Like for example, the SQL statement, the root page, all of this information we have not set properly, right? So now we are updating the schema table. So this again legacy schema table itself, which is the SQLite master. Here we are saying, see, this was the SQL statement which created. So let's actually, if we just go ahead with this. So from here again nested parse, and from here what should be called according to you? Run parser. See, what is the statement? Update this set type table. Name was the courses, table name was the courses, root page is 2, and the entire SQL command. So if you see over here, you can actually see the entire SQL command, right? So if I again do this, this is our SQL command. See, create table courses ID primary key not. So whatever SQL command we use to create this table, that entire SQL command is going to be saved in SQLite master. So now if I just go ahead, so again tokenization, parsing, all of that is going to happen. See, now it is 129. So if we go to again 129, let's go to 129, see update. So within one create table, you saw create, you saw insert, you saw select, and now we are also seeing update. So if I just move ahead, update, then main dot SQLite set type equal to table space name equal to courses, comma table name equal to courses, comma root page equal to 2, then SQL equal to the entire SQL statement. This should be one text. So if I just do this, see, that was one text, space where space row ID, again the row ID is there. And now we are done with what? We are done with the execution of update. So if I just move ahead, see parser finalize. If I go ahead, VDB set SQL. We are setting the SQL over here, and let's move ahead. And after that, so we are in prepare. If I just move ahead for now, see, where are we right now? We are back to the exec statement of which one? Our initial SQL statement. So now we are done with the preparing of our first statement that we said, the create table statement. See it properly, create table courses, whatever. So now we are done with preparing the entire thing. Now we are going to execute this. Now we are going to go to step and we are going to execute. See, we go inside this. If I go ahead, now we are in step. See, statement is now completely prepared. Now VDB is ready. Now this VDB, again from where? VDB to B-tree to pager. Now phase 1, phase 2 should happen. If I move ahead, see step, just move ahead, VDB exec. So it is going to take care of our opcodes and all. And I'm going to go ahead. See B-tree begin transaction. So from VDB to B tree, correct? And if you can read about this, about B tree, what is happening, we are starting a new transaction because we are creating the table, right? So I'm just moving ahead for now. New database, pager write. See, now from B tree to page. So now we are actually writing in the page. So let's see what is going to happen. Let's go ahead, pager write. And here, see, now I have opened a journal. Now something interesting. Okay, let's go to our terminal and see. If I do ls right now, there is demo.db and SQLite test. What was there initially? Okay, let's run now. Let's go ahead. See VFS, you remember VFS layer, we have hit that. And if I just go ahead, see, journal open. Okay, again, let's check what is there. Only two things. Let's come back and let's run again. And now open file. What file is being opened? Debug something something. So here you can see demo db journal. Journal is what? It is going to be created as temporary. It should be deleted later also. We are creating it and it should be deleted once the transaction is over. So right now again I am showing you. See, there are only two things. If I just move ahead, now we have opened, and if I do ls now, see, there is demo db journal. And this should be deleted once we are done with this entire transaction. So once I come back, see, I go ahead and I'm going to continue and I'm going to continue. So open is done. Okay. And here we are going to make the page as dirty. Remember what is a dirty page? When the page is different from whatever is there on the DB. So we are marking it as dirty. So you can go over here. Make sure the page is marked as dirty. If it isn't dirty already, make it so. Okay, so that is what is happening over here. We are managing the dirty list. We go ahead. See, this is the linked list wala code. This is where we are managing the entire thing. Magic header. So do you remember on the page on the top there was given that what is there in the header and all. So there is magic header also, if you remember. And if I just go ahead. So this is how we are setting the page. So here you can see every page we are making the changes. We are setting the, you remember in the offset it was mentioned, see, SQLite format 3. Do you remember at the top of the file there is SQLite format 3. So this was also mentioned somewhere in the documentation. Let me show it to you. See, this is how the format of the file header looks like. Header string is SQLite format 3. This is what we just saw. After this, there should be page size and bytes, file format write version, file format read version. So if I go next, see, if we just see the data, there is SQLite 3 right now, then there is mem page and all of that. If we just go ahead, 0 page. So we are at the 0 page right now. This is how we are setting all of those information. See, cell offset, data offset, overflow, init. So we are setting, is the page overflow page or is it a B tree page? What is it? So all of that is also happening. So we are in transaction right now. Let's move ahead. Schema version. B tree begin transaction. Opcode. So we are in VDB right now. Let's just move ahead. Pager write. So I'm removing the breakpoint from here because we're going to be making the changes in multiple pages. Now we are in B tree create table. See, create a new B tree table right into this. So this is where we are finally creating the table. So there is a new B tree for every table, right? So this is where we are creating that. And see, allocate B tree page, pager write. So this is where all of this is happening. So pcache dirty, again make dirty, manage list, 0 page. I am just removing the breakpoint now. See, now in the B tree we are going to insert. So we were first created the B tree, now we are inserting in the B tree. Create table, pager write, make dirty. Okay, so we are back to preparing yet another statement, which is select all from SQLite master where all of this, right? So what we are doing right now is we are in VDB exec. So what this does is, this is like a final verification that we have created the entire table properly. So it is going to go into the legacy table, which is again SQLite master. It is going to retrieve everything and it is going to check properly that everything has been done properly. So it is going to check that there was no corruption, there was nothing that happened. See, there is one error message for corruption also, right? So here we are just making sure everything's working fine. The creation of table was successful. So we are going to select everything. It should not be a trigger, but everything else, and we are going to continue. So here again prepare, again we are in parser, again we are going to tokenize. See, select all from, so select all from main SQLite master where table name equal to courses and type is not equal to trigger order by row ID, right? So this is where we are doing the select. So again select was called. How did this happen? From our parsing we went to select. So now we are going to select from the SQLite master. This is we are finalizing this particular execution. So now that we are done with that, we can move ahead. Now we are finally executing the statement. If we go ahead to this, again VDB exec, so there will be opcodes. I'm just moving ahead. By the way, we should check if we do ls, you can see that the journal file is still there. Let's move ahead. Continue. So exec, callback init, callback, init, callback, prepare. Now what statement is being prepared? Create table courses, the same one. Why? Because we are reading from the schema. Now let's again do this. Run parser. Again create table. Again primary key, not null, create index, all of that is going to happen again. Because now we are actually reading from the schema table and executing the entire SQL all over again. We are just making sure that that statement is running fine. And end table, so now we are done with that. SQLite 3 finalized, step. Now we are going to finally execute it. So we are in the step part, and from here where do we go? VDB exec. From here where should we go? B tree, from B tree to pager, right? Let's just move ahead for now. If I just remove this. Init callback, step, VDB exec, VDB halt, VDB finalize, DB free, VDB halt, commit, see B tree commit phase 1. If I go inside this, let's move ahead. See, pager commit phase 1, and now we are finally doing pager commit phase 1. Okay, so we are inside this. See, we are writing the super journal and we can go ahead. See, this is where we are going to be dealing with this file. And let's move ahead. We are finally writing to the page. Finally writing to all the concerned pages. Phase 1 is complete. B tree leave. Now we will go to phase 2. It is checking for all the B trees, right? Done. Now we'll go to phase 2. Now in phase 2 what happens? Phase 2 is when the journal gets deleted. So in phase 1 we just update all the information. So if we see journal is still there. In phase 2 is when we delete the journal, correct? So we go in, we go inside this. Let's go over here. We are ending the transaction as content, end transaction, B tree leave. Let's go ahead. VDB commit will happen. And let's actually check now. See, there is no journal because phase 2 got executed. So what do? We delete the journal in phase 2, right? So our understanding is clear. Congratulations. This is a great part to understand, right? Now we are coming out of VDB commit, coming out of VDB halt, VDB exec. So now we are finally done with executing our statement. I think we will be out now. VDB finalize, VDB delete, done. Freeing the DB, coming out. Finally, we are finishing with create table statement and we are done. Give yourself a huge pat on the back for staying till here and understanding the entire execution of create table statement. It must be really interesting to see that within one statement there are so many things that are happening, right? The indexes are being created, the schemas are being saved internally, and all of that happens. Now, although we have already seen insert, select, update, all of that happening, let's quickly see one insertion into the courses as well. So let's go ahead with that, and let's go ahead and inside the exec. So once we go inside the exec, you can see there's the SQL statement. Obviously, the first thing that's going to happen is lock and prepare, then run parser. So now you must be able to understand this properly, right? So now the insertion is going to happen. So tokenization, parsing, so insert into courses, ID, title. So once all of this happens, once we are into the insertion part. So right now we are going through the values. Let's move ahead. So we are into the insert. Where did we come from? From the reduce part. So from the parser we came to insert. Now we are going to move ahead, and let's move ahead with insertion. So this is just to show you one final flow. Let's see, this is how we go ahead from here to VDB to B tree. So I just wanted to see that once. So open the table and all the indices. We go ahead, parser finalize, VDB, right, set SQL. So now we are going to execute this statement. When we go inside the execution, we now have the VDB part, right? Now we have prepared this statement and all of that has happened. So the front end is done. Now we are in the back end part. So now we get started with VDB. We move ahead. So VDB part, VDB exec. So now we have the opcodes. There will be switch statement. Now B tree part, right? So B tree begin transaction. So here you can see B tree is there. Now B tree has the pages, correct? So if we go ahead, you will be able to see. So VDB accesses the component B tree uses pager. So now the component part should be completely clear, right? So see cache table lock. Then we move ahead. See now we have a mem page. Schema version, so we are getting from the page. So schema version is what? 3. We already saw that, right? We can just go ahead right now. See pager right. So if we go ahead for now, open journal. If we come back to the command line and see, so right now there are 2 things only. See here you can see that pager component is using which component? VFS component. So that part also you are able to see. This function is called at the start of the every write transaction. So this is the one where we open the journal. So if I just move ahead, journal open, and as soon as I go ahead with this, now if I go back and show you, see now there is journal. So for every write transaction this opens. Let's move ahead again. So we are making that too dirty. So if we go back, you can see we came from pager add page to rollback journal. So now we have added the page to rollback journal as well. And if we go ahead, we are going to write. B tree insert is happening. Pager write is happening. We are marking it as dirty. We are adding it to journal. All of it is happening properly, right? And so now the understanding is clear. VDB commit. From VDB commit, where do we come? B tree commit phase 1. As soon as we go inside this, we will go to pager phase 1. Let's go inside that. Say pager phase 1. As soon as we go inside the pager phase 1, what all things are supposed to happen? See. Pager flush on commit, right? Pager write. Pager add page to rollback journal. OS write, so I can move ahead. Now we are going to be in phase 2. If we see right now it is there, after phase 2 is completed, the journal should not be there. So let's come over here. See, pager phase 2, as soon as I go inside this, we are ending the transaction, right? As soon as we commit and end the transaction and we come out, see B tree leave as content, we are just leaving from everywhere. And as soon as we come out of here, see journal is gone. So in phase 2, journal is deleted. VDB finalize, DB free. We are done with the insert statement. We are finally closing our DB and we are done with one entire flow. So we first open the DB, we created the table, we insert it into the table. Select statement we have already seen multiple times from the SQLite master. It's same as that. You can try it out yourself. I would now like to really thank you for staying till the end of the video. I hope you enjoyed this. This is very interesting and very different kind of video. If you have stayed till here, you're genuinely interested in software engineering and not just doing interview prep or just doing it for the sake of work. You will look really interested because only then you would go through the entire video, and I'm really proud of you for that. Thank you so much for letting me being part of your learning journey. If you like the video, if you are finding the series helpful, please do let me know in the comments. If you have any feedback also, if you would like me to cover any more parts. Just in SQLite itself, obviously I could go into a lot of detailing. So here's the plan. We started from SQLite, which is one of the most simplest databases. And after this, we'll be covering MongoDB, Postgres, Cassandra, Redis, and a lot more. So once we cover all the databases, at least the basic flows and the debugging, then we can also start going through minute details of each of these databases, and I would love to do that. But I can do that only if I know that you all are enjoying the series, only if it reaches more people, because you have no idea the amount of effort it takes behind this. You first debug the entire thing, you analyze the entire thing, you read through the documentation, then you think how to make it simpler, and then you make sense of why are so many calls happening. Trust me, the first time I was debugging the create statement, I was literally pulling my hair that why is the parser being called so many times? Why are so many internal commands being called? Then you keep reading about it and then it makes sense to you that okay, master table, temp master and all of that. So it has taken a lot of effort, but if you think it was worth it, please do comment. Please consider sharing it with your friends or with your social media people. It would really help me a lot. Like, you have no idea how much it would mean to me. It is literally morning. By the time I keep recording, it takes me entire night to record like one video. Just being honest over here and sharing something with you. And if you would like me to be part of your further learning journey, if you would like me to help you with interview prep or with project building, do consider signing up for any one of our courses, LLD, HLD, DSA, HHLD. There's a lot on Educosys. Go check it out. I would love to teach you live or to be part of your learning journey and make it more faster, quicker, because YouTube has its own limitations. I don't know you personally. If you would like that connection with me, please do consider signing up for Educosys. Otherwise, see you next time. See you in the next video. Please do comment and let me know if you found this helpful. Bye.